lecture. Sorry. We're talking relation. On. Please keep your mic off. Keep your mic off. If you are not talking with me, then don't turn on your mic.
Sir, can you please speak a bit louder?
Yes, is it clear now?
Yes, sir.
Okay, so let me revise what we discussed so far. So please keep your mic off. Don't turn your mic on if you are not talking with me. Okay, so what we discussed last time, we discussed about equivalence relation, right? Equivalence relation, if it is reflexive, symmetric and transitive, then relation is called as equivalence relation. Also we talk about equivalence classes, right? So what are the equivalence classes? R is the equivalence relation, X is a element in set A, then equivalence class of X with respect to relation R is the set of all elements in A which are related to X with respect to relation R. So equivalence class of X is denoted by this symbol. And what is the class of X? Those elements which are related to X, that is a class of X. Right, so those elements which are related to X, which is called as equivalence class of X. Right, so this is set ABC and R is a relation on set A. Then if you see the relation equivalence class of A, then what are the elements related with A with respect to the relation? So A is related to A is related to C, right? And so therefore A and C are in class of A. B is related to B only. B is not related to any other element. So the equivalence class of B contains only one element. C is related to C. So C is in equivalence class of C, and also C is related to A. Therefore A is in equivalence class of C, right? And therefore we constructed equivalence classes of elements in set A. And also we can observe some things that union of all these classes gives us the entire set. Fine. So all of you are comfortable with the equivalence relation now, right? So equivalence relation, equivalence classes. And we saw the example that if we consider all the students in the college, right, set of all students in the college, if we define relation R on the set of all students in the college, where two students are related if uh, X and Y are from the same class. Same class means what? They are from FYBSC A division, then they are related. Right? If X is from A division and another Y is from B division, then they are not related. So then this relation is clearly reflexive, symmetric, transitive, so it is equivalence relation. And if you try to construct the equivalence classes, if you choose any student from the all the students, set of students, Then what are the students related to X? All the students which are from his class, right? If I select student from FYBS A division, then all the students from A division are related with that student. And therefore, if I construct this class, so I will get class of A division, B division, C division, SYBSC A division, whatever all the classes. And therefore, entire set of students will be divided into various classes. Right. This is what we observed from the equivalence relation. So now I will define one more relation. For example, let my set A is equal to R, set of real numbers. Now you know what is a R, set of real numbers. Set of real numbers. Now I am going to define a relation what I should say, this R. Now you understand difference between this R and this R. Do you understand difference between these two R's? Right? So there should not be confusion. This is just our simple
Yes, sir.
R and this is real number, set of real numbers. So these two are not same R, that you should note. So define relation R on set of real numbers as for xy belongs to R, x related to y if x square is equal to y. If this is my relation, right? Now questions are, question 1, is R an equivalence relation? Is it an equivalence relation?
No, sir.
No, sir.
Right.
No,
So
sir.
for example, for if I take x is equal to 2 and y is equal to 4, right? Then what is x square? X square is 2 square, that is 4, which is y, and therefore what can I say here? 2 is related to 4. 2 is related to 4. Now this is what the two elements are related. If one second element is square of first element, then x is related to y. Now is 1 related to 3? Is it true? Is 1 related?
No, sir.
No, right? Because 1 square is not equal to 3. Therefore, this is not related. 1 is not related to 3. That you can easily understand. Now, R is not reflexive. So, this relation is not reflexive. Because why? So, why it is not reflexive? Because, for example, x is equal to 2, then 2 is not related to 2. Right? 2 is not related to 2. Why 2 is not related to 2? Right?
Because condition.
Because see, if 2 is related to 2, then by definition 2 square must be equal to 2. That means 4 is equal to 2, which is not true. Right? So it is this is contradiction. Therefore, 2 is not related to 2. There are many such elements. That means there are many elements which are not related to itself. So therefore, if we can produce at least one evidence where the x is not related to x, right? So therefore, R is not reflexive. So we can produce one evidence where element is not related to this. Similarly, R is not symmetric, right? Because 2 related to 4, but 4 is not related to 2. So symmetry fails. There is a pair, right? There is a pair 2 comma 4 in R, but 4 comma 2 is not in R. So the symmetry fails. What symmetric relation says, if X is related with Y, then Y must be related to X. But 2 is related to 4, but 4 is not related to 2. So there is an evidence where the condition of symmetry fails. Therefore, R is not symmetric. Similarly, it is not transitive also. R is not transitive. What is the evidence? Why R is not transitive? What is the evidence?
2 is related to 4 and 4 is
Uh,
related to 16, but 2 is
ah,
not related to
right. So very good. So 2 is related to 4 because 2 square is equal to 4. 4 is related to 16 because 4 square is equal to 16. But 2 is not related with 16 because 2 square is not equal to 16. Right. So that you can understand. Therefore, this relation, this particular relation, this is a relation. Right, because some elements are related, so this is a relation because it is a subset of R cross R, but it is neither reflexive, it is not reflexive, not symmetric, not transitive, just relation. Right. Now second question I would like to ask, so this relation R, see, we know that what is the relation R? R is a subset of A cross A, right? R is a subset of A cross A. But in this case, what is A cross A? R cross R. Because A is set of real numbers, right? A is set of real numbers. So what is uh, R cross R? Do you know what is R cross R? What is R cross R? What is R cross R?
R.
R2, right? The XY plane, which we call it as XY plane. What is R2? R2 is XY plane. Right. Do you understand this? R2 is XY plane. The first component is from this real number, this set, and second component is from this set. So R2. Now, can you write down this relation R? What is the relation R? Those XY. Now, can you tell me what is X? What are the pairs XY? What is the relation between X and Y with respect to same what defined above?
X square equal to y.
X square equal to Y.
So y is equal to x square or x square is equal to y. This is my set R relation, right? So x is related to y if x square is equal to y. This is what my relation is. Fine. Now can you sketch? So if I saying that this is a subset of R2, that means it is a subset of, can you sketch the relation R as a subset of R cross R, which we call it as R2? The question is clear, right? The first of all, try to understand the question. What question says? Question is clear or not? Sketch or draw. Question is clear? If you have any doubt, you can ask. The question is clear or not? What I am asking. Do you understand? R is a subset of what? Relation is a subset of set A cross A, but A is R in this case, so R cross R, that is R2. And you know what is R2 or R cross R? The pairs, plane, right? XY plane. So now what is my relation? Those pairs xy such that the second component is square of first component. This is my relation, right? And definitely it is a subset of R2, that means plane. Can you sketch this subset, this relation R as a subset of R2? The question is clear or not? Right, this is a real line, this is a real line, right? Then so this is a real line, this is a real line which we call as first as a x-axis, second as a y-axis, right? Now can you tell me, do you understand what is the set?
Your screen is not visible.
Screen is not visible. Is the same problem with everyone?
Yes, sir, it is.
No, sir. No, sir.
No,
No, sir. It is
sir, it's visible.
Yeah, so see, this happens due to the internet connectivity. Sometimes it depends on your internet connectivity or maybe my internet connectivity. But if some people can see, that means it is a internet connectivity with some individual, right? So anyway, don't worry, you will get it after some seconds. So okay, so do you understand the question first of all? Do you understand the question?
Sir, please repeat.
See, what is my set on which relation is defined? Real numbers, right? The set on which I have defined the relation is set of real numbers. Fine. Now relation is a subset of what? A cross A, but A is now our real numbers in this case. So my relation is a subset of plane. Is it clear? First sentence is this sentence is clear. My relation is a subset of R2 or XY plane. This is clear or not?
Yes.
yes, sir. Yes,
Right.
sir.
Very good. Now, what is my relation now? Those pairs x comma y for which y is x square. Now this is clear.
Yes, sir.
Yes.
Right.
Yes,
Now
sir.
can you sketch this said relation as a subset of R2? Now what are the pairs xy for which y is equal to x square?
Draw parabola.
Right. Very good. So what are my all points which satisfy this condition? Parabola y is equal to x square. Right, so now I can sketch the relation as a subset of R cross R plane, right? So what is a parabola? This parabola is actually the relation R. All points on this parabola satisfy this condition. Is it clear? Now the question is clear.
Yes, sir.
Yes, sir.
So very good. So therefore you can actually see the relation as a set in plane. This is what the interesting thing you can understand. All right, fine. Now I will ask you one more question. My set is again set of real numbers. Set of real numbers. Now define relation R on, define relation R on uh, this set A or set of real numbers as for xy belongs to R, x related to y, if x square plus y square is equal to 1. So when two elements are related, right, when two elements are related, then if their sum of squares is 1, for example, can you tell me any pair which is related with respect to this relation? Can you tell me at least one pair? I will take x is equal to 1 upon
0
0.
and 1.
Right, 0 and 1. This is the simplest pair that you can. Then what is x square plus y square? 1 by 2 plus 1 by 2. Yes. So this pair is, so therefore 1 by root 2 is related to 1 by root 2, and x is equal to 0 and y is equal to 1. This is one pair because x square plus y square is 0 square plus 1 square, which is 1. So what is the conclusion? 0 is related to 1. Right, so that is fine. Now, but if I take, for example, 1, x is equal to 1. Now, is 1 related to 1? Is 1 related to 1?
No.
No,
No, sir.
Right?
No.
Because 1 square plus 1 square is 2, which is not equal to 1. So what is the conclusion? 1 is not related to 1. So there is an evidence for which the reflexivity fails, right? Therefore, this relation is not reflexive, right? So this relation is not reflexive. Is it symmetric? Is it symmetric?
yes.
Yes.
Symmetric,
sir.
right? So if
Yes.
x related to y, that means x square plus y square is 1. So that y square plus x square is 1, and therefore y is related to x. So whenever x is related to y, y is also related to x. So therefore R is symmetric. Now is R transitive? Is R transitive? So is this relation transitive?
No.
No,
No,
sir.
this is not transitive. For example, 1 is related to 0 and 0 is related to 1, but 1 is not related to 1. So this is the evidence for which transitivity fails, right? Therefore, this relation is not equivalence relation. Not equivalence relation, because for equivalence relation we need all these three properties to be satisfied. But here the two properties fails, reflexivity and transitivity. If one property fails, then also it is not equivalence relation. And it for this relation the two property fails. It is symmetric, but that is doesn't an issue. Fine. So can you sketch now again? So R is a subset of what? R cross R, which is plane.
A cross A, that is set of real.
It's plane, right? So XY plane. So it is a subset of XY planes. Can you sketch?
Yes, sir, it is a unit circle.
So let
Yes, sir.
sketch R as a subset of R2. So now you can certainly sketch it. And what is relation R? The circle of radius 1 center at
Unit circle of
origin.
radius 1.
Right, x
One,
square
sir.
plus y square is equal to 1. So this is actually relation R. So every point on this circle, right, the collection of all points on this circle is actually our relation. Right, this is how interesting you think you can observe. So you can actually see the relation geometrically. Right, and you should just try to search such relations and sketch the relations as a subsets of plane. Right, fine. So now I will go to some different kind of thing, which is uh, okay. So let A is equal to, now I am taking plane R cross R, right? So you know what is R2. First of all, tell me, do you understand what is R2? Is there any confusion?
No, sir.
What is R2? XY, such that X and Y are real numbers. And generally we call it as XY plane. Right, so R2 means X comma Y. Now this is my set A. This is my set A. Understand this. So what is my set? All points in the plane, XY plane. This is my set. Forget about previous thing. In this case, our set was real numbers. Right? In this case, set was real numbers, real line. and my relation was subset of R2, R cross S. So now for instance, forget about previous part. Now look at this. My set is plane, all points in the plane. Right, so all points in the plane, this plane, entire plane. Now you can understand the plane. Now on this plane, I want to define a relation. Define a relation relation tilde. Now I am using different notation due to some reason. So relation tilde on R2 as, okay, so now I am going to define a relation on this set. So from your previous experience, how should I define? How should I define the relation? Okay, what is the definition of that relation? That is a different story. But first of all, I should take two elements. What are the elements? For I will take two elements from this. Right. So what is, I will take first element x1, y1 and x2, y2. These are two elements from my set or plane, right? These two elements are related with respect to this relation. Now I am using the symbol tilde. Remember this for relation, right? So two elements are related. X1, Y1 is related to X2, Y2 if X1, Y1 is related to X2, Y2 if and only if X1 plus Y1 is same as X2 plus Y2. Do you understand how what I am doing? First of all, observe that my set is R2 plane, and therefore I am going to define a relation on between 2 points, right? I am going to define a relation between 2 points, right? If 2 points are related, if the sum of their components is same. Do you understand this? Points are in the plane now. In previous case, our points were on real line, and therefore I took x and y, and when x is related to y, that was a different thing because I was on line, real numbers. But now I am not on line. I am in the plane now. You can take your plane of table or plane of paper, and you choose 2 points, and 2 points are related if, when 2 points are related, if the sum of their components is equal. For example, if I take 2 comma 3 and 1 comma 4, are these 2 points related? Are these two
Yes,
points?
sir.
Yes,
Yes.
sir.
3 plus 3 is 5 and 1 plus 4 is also 5. Therefore, these 2 points are related. These 2 points are related. Fine. Now, if I take 2 comma 3 and 5 comma 7, are these 2 points related?
No.
No, sir.
No, sir.
No.
Because 2 plus 3 is 5 and 5 plus 7 is 12. They are not equal. Right. So, these two are not related. Right. So, now you understood that what is this relation actually? This relation
Yes,
is
sir.
if sum of two components is equal, then these 2 points in the plane are related. Now, the first part is it reflexive? Is this relation reflexive? Is this relation reflexive? Right? How should I verify whether it is reflexive or not? How should I verify it?
By putting y1 is equals to x1 and y2 is equals to x2.
Yeah, no, actually what I should take, I choose any arbitrary point. I just close my eyes and choose any point from the plane, not any particular point. So just close your eyes and choose any point from our set R2, right? My set is now R2, right? Then My question is xy related to xy? This is my question. Right, this is my question. That is in my mind. I want to check its reflexivity. That means I just close my eyes and choose a point from the plane, and I will check whether that point is related to itself. That is a simple thing, right? That means is xy related to xy means is x plus y same as x plus y. That's what
Yes, sir.
so that I will ask to myself,
Yes.
Yes.
right?
Yes,
So
yes.
So if I choose arbitrary point from my state R2, then I know that x plus y is same as x plus y because the same xy and xy I am taking. That means xy is related to xy. What is the conclusion? Therefore, for every for I am making confusion here. I am using symbol tilde here for relation. So I should not make these mistakes. So I am using symbol for my relation here. Alright. So for every xy in my set R2, xy is related to xy. Therefore, this relation is reflexive. Okay, this is clear. This part is clear.
Yes, sir.
Yes, sir.
Very good. Now let us go to the next property. Symmetry. Now I want to check whether it is symmetric. So how do I check with symmetric? Suppose A comma B and C comma D are two elements in my set such that A comma B is related to C comma D. Suppose A comma B is related to C comma D. Then my question I will ask in myself is C comma D also related to A comma B? That is my in my mind. That is I want to check, right? If A comma B is related to C comma D, that means if this point is related to this point, then I want to check whether this point is also related to this. So that is in my mind. So but if when I am saying A comma B is related to C comma D, that means what? By definition of relation, what I should say then? When A comma B
A
is
plus
A plus B
is
is
A
equal
equal
to
plus
to
B
C
is
plus
equal to
D.
C plus D.
very good. So it is C plus D. When I say A comma B is related to C comma D means the sum of components are equal. That means C plus D is same as A plus B because no
A
matter which
plus B.
right, so which side is first and right side and left side are equal, so I can change their sides, so that is not an issue. But what does it mean if sum of components is same? What does it mean?
C comma D is equal, related to A comma B.
Related to A
Very
comma B.
so C comma D is related to this, and therefore this is true. That is what was in my mind. I am assuming A comma B is related to C comma D, and I was thinking about whether C comma D is related to A comma B, and that is true. Right. Thus, what is the conclusion? If A comma B is related to C comma D, then C comma D is also related to A comma B. And this is true every time. Whenever A comma B is related to C comma D, then definitely C comma D is related to A comma D. Doesn't matter what pair you selected. If this happens, then this must happen. Hence, R is symmetric. Please keep your mic off. Somebody kept mic on. So please don't forget, it creates disturbance. Right? Okay, so fine. Is the relation is now symmetric? Are you comfortable with this?
Yes, sir.
Okay, now
Yes, sir.
third part, transitivity. Now I am going to check its transitivity. So how do I check the transitivity? Suppose A comma B is related to C comma D, and C comma D is related to R comma S, then what is the question in my mind is A comma B related to R comma S. This is in my mind. If this happens to be true for any such situation, in any such situation, if this happens to be true, then I can declare that my relation is transitive. Right. Suppose A comma B is related to C comma D and C comma D is related to R comma S, then I want to check whether A comma B is related to R comma S. Right. So whether A comma B is related to R comma S. This is what I want to check. So since A comma B is related to C comma D, please keep your mic off. We have A plus B is equal to C plus D, and C comma D is related to R comma S. Then we have C plus D is same as R plus S. Is it correct?
Yes, sir.
Yes. Yes,
Right.
sir.
And therefore A plus B is same as C plus D, and C plus D is same as R plus S. What is the final conclusion?
A plus B
Yes,
equal
A
to R
plus B
plus
is equals
S.
to R plus S.
R plus S. So ultimately what we get, A plus B is equal to R plus S. But by definition of relation, A comma B is related to R comma S.
R comma S.
Right, and every time this is going to happen. Whenever A comma B is, whenever one element is related to second and second is related to third, then first is related to third. So every time this is going to happen. Right. That means there is no evidence कि A comma B is related to some C comma D, and C comma D is related to R comma S, and A comma B is not related to R comma. That's the such evidence you cannot produce at all. Right.
So we should
Then,
also mention that A comma B, C comma D and R comma S belong to R square
yeah,
before.
where that is understood actually, because I am choosing elements from my set and I am assuming the same relation. That's fine. Okay. But for better, more precise, you can mention that also. No problem. Right. Okay. So therefore, relation is transitive, right? Hence, the relation is reflexive, symmetric, and transitive. Therefore, the relation is
Equivalent.
Equivalent.
this particular relation is now equivalence relation. Once we are sure, and that is the reason why I denoted the relation by tilde. Right? Equivalence relation is always denoted by this symbol that we mentioned in the previous lecture. So my relation is equivalence. This is not you can denote by R also. This is just notation, whatever is notation. The only thing is the convention is that he denote by tilde. So and the equivalence relations are useful for us for some purpose, right? So this is equivalence relation. Now we can talk about equivalence classes. We can talk about equivalence classes. So now my next question is what are equivalence classes of this set R2 with respect to equivalence relation tilde? So this is my next question. What are the equivalence classes? So we'll do very slowly, because you can understand. If you understand one problem clearly, then the next part will be very easy for you, right? For example, I choose some point xy is equal to 0 comma 1. I will select this point. And now I will ask a simple question. What is equivalence class of this particular point? Right? This is a simple question you can ask yourself. Right? Suppose you don't understand the general problem, you just go to the very particular simple case and ask yourself, what is it? Right? So we know that by definition, what is equivalence class of 0 comma 1 is denoted by this symbol, or 0 comma 1 bar, anything, any symbol you can use. And by definition of equivalence class, what is it? What is equivalence class of this element? What is equivalence class of this particular element? Is the set of all those points in my set A, which is R2, such that these points are related to 0 comma 1. Am I right? Am I right?
Yes, sir.
Very. Therefore, this is a set of all those points in my set, which is R2 in this case, such that xy is related to 0 comma 1 means what? X plus y is equal to 0 plus 1. Right, that means it is a set of all those points in my set R2 such that x plus y is equal to 1. Now you can understand what are the points in R2 for which xy is equal to 1. Now can you tell me what is this set?
Sir,
What is this? This is my set now. This is my set A, R2, that is a plane, xy plane. My set is now R2. And in this set, what is my equivalence class of 0 comma 1? 0 comma 1 is here. 0 comma 1 is here. Right? Is it clear? 0 comma 1. Now what is the class of 0 comma 1? What is the class of 0 comma 1? Do you understand? Those points in my set which are related with 0 comma 1. But what are the points which are related to 0 comma 1? This
1,
condition.
0.
No. You
Sir,
tell me.
x
Yes.
plus y is equal to
So if point is in class of 0 comma 1, then sum of components is 1. Then sum of its components is 1 means what is it? What is x plus y is equal to 1?
line.
Line.
For
line.
example, 1. Oh, I am writing something. 1 comma 0 is here and 0 comma 1 is here. So 0 comma 1, I want to see the class of this. And 1 comma 0 is also in the class of 0 1. 1 comma 0 is in class of
Yes, sir.
0 comma 1. Right? That is clear because 1 comma 0 is related to 0. So these 2 points are in same class. And what are all other points? All points on this line x plus y is equal to 1 passing through these 2 points. Right? This is line x plus y is equal to.
It is linear equation.
Right? What? Pardon? It is linear equation. That's fine. So this represents straight line because what are all the points in the plane which satisfy this condition? Right? Which are the elements in the class of 0 comma 1? All the points in
The
plane
points present on line.
right. So all the points on this line are in the class, and therefore what is the class? Therefore class of 0 comma 1 is a line x plus y is equal to 1 in my set. Right? These are all the points or every point on this line. See, if you recall my previous example, all the students in the college, and I defined the relation if two students are related, if they are from same class, then what is the class of student of A division? I select some student from A division. What is its class? All the students from A division is its class. Therefore, what is the class of 0, 1? All the lines on this, all the points on this line are in class of 0, 1. Is it clear now? This idea is clear. What is the class of 0, 1? Is it clear? Okay.
Yes, sir.
This is my first example in this particular case.
Sir.
Yes. So what is class of, for example, what is the class of 2, 3? Can you understand class of 2, 3?
X plus y is equal to 5.
So class of 2, 3 is those points x, y such that x, y is related to 2, 3. That means those points x, y such that x plus y is equal to 2 plus 3, that is 5. And therefore you understand what is this set?
This line.
Line x plus y is equal to,
Yes.
right, x plus y is equal to 5. And moreover, you observe that key point 0, 5, 0 is in the class of 2, 3. Is it true?
Yes,
Yes,
sir.
sir.
And
Yes.
therefore
Sir.
the 5, 0 is here, and 0, 5 is also there. What is the relation between these two lines? What is the relation?
Parallel line.
These two
Parallel line.
lines are parallel.
Very good. Now I want to generalize my problem. So let AB belongs to my set. Then what is class? Equivalence class basically of AB, right? So equivalence class of AB is those points in my set such that that point is related to AB. Right, means what? Those points for which x plus y is equal to a plus b. Now I have fixed my point AB, and therefore a plus b is a constant. A plus b is constant. Do you understand this? If I fix my point AB, then a plus b is constant.
Yes.
Right, and therefore all those points for which x plus y is equal to this constant a plus b. But if you observe this line, so again this a plus x plus y is equal to a plus b is constant. This is a line. Is it clear? This is
Yes.
Yes.
now this
Yes.
is a line, and what is the slope of this line?
Minus.
-1. Very good.
-1.
And what is the slope of x plus y is equal to 1?
Minus.
Minus.
And therefore
Minus
whatever
1.
whatever point you select AB doesn't matter, its equivalence class is a line parallel to these lines. Do you understand this? No matter what point you select, you select point, for example, 200, 500, doesn't matter. What is the class of this point? Or 2020, 2019. I select this point. What is the class of this point? A line, but slope is -1. Whatever. What changes? If you change the point, what is the change? Intercept changes. Right hand side changes. This side doesn't change. Is it clear? And therefore you select point whatever, I will get equivalence class is a line parallel to these lines. And therefore what are the equivalence classes? What are equivalence classes? You understand? The idea is clear now? Do you
Yes,
understand?
sir.
And therefore, what are the classes? All the lines, right? And therefore, all the lines, if I just collect all the lines and if I arrange all these lines one after another, then what I will get? Plane, right? It is exactly similar to the previous example which we discussed. If we arrange all the classes in the college one after another, I will get all the students from the college. Similarly, if I just arrange, so, and how many classes are there now? How many equivalence classes are there? How many equivalence classes are there? How many lines are there?
Infinite.
Infinite
lines.
means, right? Very good. Please keep your mic off. Okay. So, and you can observe the x-axis. You select one point on the x-axis, then, and every line, every such type of line intersect x-axis somewhere, right? And you choose point on x-axis. There is a line passing through it parallel to which slope is -1. Therefore, you can take these as a representatives. These as a representative. Every point on real line is a representative, and if you choose distinct points on real line or x-axis, you will get distinct classes. This is what the classes, equivalence classes. So this idea is clear. Any doubt in this?
No, sir.
So therefore, equivalence class of AB is a line whose slope is -1 and intercept is y-intercept is
AB0.
right, y-intercept is a plus b, right? So every time whatever your point is, only intercept changes, the slope remains unchanged, and therefore parallel lines. Thus the equivalence classes are parallel lines. What are equivalence classes? Parallel lines with slope -1. Right. So equivalence of
നീ അവിടെ എവിടെയും പോയിട്ട് ഓരോന്ന് തിന്നോണ്ട്.
See, you people do not care about this thing. You should keep your mic off if you are not talking with me, right? I am repeating this again and again, and it creates disturbance. And if you like create disturbance, then it is fine. Do you like creating disturbance? Right? So you have to be very careful. You are now very aware of technology and all these things, so you should have to be alert. It should not create disturbance to the class, right? Okay. So equivalence classes are parallel lines with slope -1. And see, it is like if you can assume this as a sticks, and if you arrange all these sticks one after another, then these sticks will infinite sticks. These sticks will fill up this plane, and therefore all these lines together will fill up entire plane. And how many classes? So there are many classes. There is again after this line there is next line. After this there is next line. There is no gap at all. Right? That is difficult to see, but there are very close to this. There is one more line. There is one more line. So if you combine all these classes, we will get entire set. That is R2. So that is what the relation is. So this is a perfect example here. You can understand what are the generalization of these things. What are the classes? Right? Now I will take same set R2 and define relation tilde on R2 as x1 y1 x2 y2 belongs to R2, x1 y1 related to x2 y2 if and only if x1 square plus y1 square is same as x2 square plus y2 square. Right, so this is a relation. Relation is clear. Two points are related if sum of squares of components are same. That is what the relation is. Now work out all the previous exercises. In the previous problem what we did, right? Work out exactly the same in similar manner. So, right, check whether is equivalence relation, right, and determine equivalence classes. Okay, so determine all the equivalence classes. So work out, repeat all the previous exercise, previous thing for this particular relation. Repeat all these above things for this relation and sketch, draw the classes. This is a sketch of classes. So classes are this. So now what are the classes here? You can observe. Right. So the idea is clear now. So this is something generalization. And do you understand? Right. So idea is clear. Any confusion? Any doubt?
No, sir.
Right, so idea is clear.
Nice.